Okay, so these are the practice problems from the molarity notes. Begins with, what is the molarity of a solution made by dissolving 0.65 moles of MgCl2 in 0.325 liters of water? So we know that molarity is equal to moles of solute, which is the substance getting dissolved, divided by the liters of solution. Okay, so in order to calculate the molarity, which is capital M, all we need to do is take the moles of solute, which is getting dissolved, so that's our MgCl2. There are 0.65 moles of it. And we're going to divide that by our liters of solution, and it's happening in 0.325 liters of solution. So for this one, it turns out that the molarity is going to wind up being, if you plug this into a calculator, it'll be 2.0 molar, which is abbreviated with a capital M. That just means the molarity. And then you just put of the substance that was dissolved, MgCl2. Okay. So the next practice problem, we've got how many moles of CaO are needed to make 2.4 liters of a CaO solution with a molarity of 0.25 molar. So in this one, we're not trying to solve for the concentration because we've already been given that. We're trying to solve for moles of the solute. Well, it begins the same way. Molarity is still equal to your moles of your solute divided by your liters of solution. Except for this time, we're not trying to solve for molarity, we're trying to solve for moles of solute. So we need to get moles by itself. Since it's being divided by liters of solution, we'll multiply both sides by liters of solution. Do the same over here, liters of solution. Now on this side, these are going to cancel. So that's going to leave us on the right side with moles of solute by itself, which is good because that's what we're trying to solve for. And that's equal to your liters of solution times your molarity. Now, since we're just trying to solve for moles, we'll just plug in liters. There are 2.4 liters of solution. 2.4 times our molarity, which is 0.25 molar. We'll just plug it into our calculator, and that will tell us our moles of solute. So 2.4 times 0.25 turns out to be 0.60 moles of our solute, which in this case was CaO. Okay, so the next practice problem. What is the concentration, so we're looking for molarity, of a solution made by mixing 5.5 grams of MgCl2 in 0.75 liters of water? So once again, molarity is equal to your moles of solute divided by your liters of solution. What is the concentration? So we're looking for molarity. It's in 0.75 liters, so that's our denominator. But the problem here with the numerator is we need moles of solute, and we were given grams of solute. So we have to first convert this 5.5 grams of MgCl2 to moles of MgCl2. And to do that, we need the molar mass. So if we look at our periodic table, we need to find the molar mass of MgCl2. Well, the molar mass of magnesium from the periodic table is 24.31. At least I hope so. I'm doing that from memory. Plus chlorine, which is 35.45. But there are two of those, so we need to multiply that by 2. So we'll just plug this into the calculator real fast. And the molar mass of MgCl2 is 95.21 grams per mole. So now we can use dimensional analysis to go from grams of MgCl2 to moles of it. put what you're starting with on top. We've got 5.5 grams of MgCl2, and we want to take that to moles. So since I want grams to cancel, I'll put grams of MgCl2 in the bottom, trying to get to moles of MgCl2. So now I just need to make my true statement. 1 mole, we said from here, weighs 95.21 grams. So multiply across the top, divide on the bottom, and you wind up having 5.5 divided by 95.21, which is 0.058 mole of MgCl2. Now we're not done. We did all that work just to get this grams converted into moles of our solute, which now we can come up here and place into our equation. So in order to find the molarity, we'll just set molarity equal to your moles of solute, which is 0.058 moles, divided by your liters of solution, and this is happening in 0.75 liters. Okay, so to find our concentration or our molarity, we'll just take our moles, divide it by 0.75, and it turns out this is a 0.078 molar, capital M, solution of MgCl2. Okay, and the next and final practice problem. What's the concentration of a solution made by dissolving 2.2 moles of lithium chloride with 750 milliliters of water? So one more time. Molarity is moles of solute over liters of solution. And the problem here is this is in milliliters. We have to convert it to liters first. In order to go from milliliters to liters, though, it's just an easy calculation. Just divide it by 1,000, and that will convert you from milliliters to liters. So this is 0.75 liters. So now we can just plug it in. We've got 2.2 moles of solute in 0.75 liters. So we'll just take 2.2 divided by 0.75, and we'll round it off. That comes out to be 2.9 molar lithium chloride.